image up, and I will pull that image and I'll start my work. So what I did, let me say Nginx or Prometheus or Grafana, whatever is there, there will be an image, okay, or there will be a Helm chart. So you do something like this. Helm, first you add the repo. So you say Helm repo add, then give a name of your choice, whatever name you want, and then there will be a URL, right? So this is what we have. We have Helm repo add, you give any name of your choice, and finally you have a URL here. So the important thing is this URL, then this command Helm repo add, and then you put it in your local machine by this name. Then from your local you say Helm install, then whatever name you have given here, my repo, and inside that I'm looking for Nginx. And here while installing you give another name. So basically if I do this much, I avoid or I save some piece of writing of code. I don't have to write the code from scratch, rather I can simply use it in the way I want to, or it is there present. Obviously in case I want to edit, I can make some changes. So today what we will do is we will go ahead and create our own Helm repository. Okay, we'll create our own Helm chart and we will use it as per our requirement. So basically what I will do is I will go, and there is something called, there's a document called okay. So there is a document which I will share with you. Okay, the link and all I think I've already shared in the group. In case I've not shared the link, I will share this link with you. And here it will show me how to create a Helm chart, your own Helm chart, where you go and put your content, and then based on that you push it to Artifact Hub, and then you can publish it so that any other user can use it. It is very similar to the Helm repo which Docker Hub which we have. So there are images readily available, you can use it. But in case you want a customized Docker image which you and your company members want to use, you push a customized Docker image to your private repository, and from there you use it. Now here again we are going to do something very similar to this. Now here it says that to work with this you need to have three things. Okay, you need to have Kubernetes, and then you should have Helm install on that Kubernetes, and you should have an active GitHub account. So what I will do is I will start with that. So the first thing what I will do is I'll go and look for interactive Kubernetes shell, and I will open my I will open my interactive shell. Okay, once this is done, let me just come here. So let this come up. So this is my interactive shell where Kubernetes is available. Now I will also go ahead and look for Helm. So let me go to my GitHub account. And here I have the set of commands which I can use to install Helm. So let me come here. Helm installation. And you can run these commands, basically, these three commands. Wait, there's a small problem.
So we have to mini-queue
do that only. So I'm just starting my environment first, and then I should go ahead and run all these three commands. So that's what I told. I made a small mistake. Should have done minikube start, and then I should have started with this. Anyhow, we have made that change. So let's wait for the control plane or my master node to come up, and after that we can publish our things. Okay. Okay, so it is done. Let me run those three commands which I was planning to run. So this is the curl command, first one. Then the second command was this thing, and then run the script with this particular stuff. So this will go ahead and install Helm for me. Now once it is done, you can come here and check Helm version, means Helm is installed. So it shows me a Helm version. So basically, as per this document, I have a Kubernetes environment available, Helm installed, and I should have an active GitHub account. So this is my GitHub account, like whatever you have your GitHub account. So these three things are required. I have all three of them. Now it says to create a Helm chart, what you have to do is you have to first go ahead and create a folder with the name as my web. You create with any name, that is up to you. Create with a name, with a folder with the name as my web, and here you go inside the folder and create a chart.yaml. Now chart.yaml is the basic file which contains the metadata related things. So in chart.yaml, you can write these things: API version, name, version, application version, and description. Obviously, these things can change. Like instead of writing API version v1, you will write API version v2. You will write your app name as my web. You can give a demo web. Means again, you can give any name of your choice. It is up to you. Okay. Then these things can change, but the keywords can remain as it is. Okay. Then what you have to do is you have to go here and create your resources. Means inside your Helm chart, what all you want to put. So you can go ahead and go inside my web folder only, where you have created this chart.yaml. Inside that only you create another folder with the name as templates, and in the templates you go ahead and put whatever you want to. So here if you see, there is a deployment file which has been put, there is a service file which has been put. Now let me show this to you in the console. So what I have done is I have already done all these things. So I have a GitHub repo where I have all this content. So you can simply fork it and use it. So this is my GitHub repo, httpd web server Helm chart. So if you see here, this is my folder. These all are not needed. Okay, if you want, you can delete all these guys. So this is what is needed. My web. Go inside this folder, my web. Here, this is your charts.yaml. Here, just a copy paste of what is written here. And if you want, you can change. That is up to you. So this is chart.yaml, which I have simply copy pasted here. This is my chart.yaml, v1, my web, and all those things. Then come back to my web. Here I have created another folder with the name as template. And in the template, you put all your stuffs. Like I have put one deployment file, which is this. So if I go here, I say apps v1, it's a deployment. In the metadata section, I've given creation timestamp as null. You can give your timestamp if you want. And most important thing is label. So this label is my deployment, something like this, my deployment. The name also has been given as my deployment. So it is up to you what name and label you give. Then if you come here, there are two things which you need to see. One is I have not hard coded the value as replica equal to 3, something like that. I've not written. What I have done is I'm saying there will be a values file, and inside that values file there will be a variable called replica count. Take the value from there. So dot values means it is present here only in the same folder. And here if you come, you can see I've used a customized image. So this web page is nothing but it's a customized image which is present here in my Docker Hub. It's a public image, so anybody can come and take it. So if I come here to my Docker Hub, let me sign in. Go ahead and continue. So if I go to this guy, here you can see that I have a customized Docker image with the name as web page. If you want to go inside and see what is there, it is nothing but a simple web page. You can go inside this latest. And here you have a very simple Nginx web page with this CMD and all. So while teaching, I might have shown you this. Okay. So this is a very simple customized Docker image, which I have created here. So I am going to use this image. So let me again come back here. And here I'm showing you two new things. One is replicas. I'm not hard coding the value, rather I am passing it as a variable. Second is rest and all is same. Rest and all you leave. Rest and all is not that important. The second thing is your image. If you want, you have selector, you have template, and you have spec, which is almost similar to what you see in your any YAML file. Then in the similar way, I have also created a service file. Okay, in the service file, I am saying v1 service. In the name app label, I have given my SVC. If you want, you can give any label of your choice. And here we are saying that the port number is going to come from values file inside that my service, inside that port. And it is nothing but it is a load balancer. And the type also will come from values file, my service type. Okay, so this type of a code I have written. Now, suppose you have 20 different deployment files, 10 service files, 5 secret, 20 config files. So whatever you want to generalize or whatever you want to put in your Helm chart, you put all the files here. So while starting Helm, I told you create once and use n number of times. So while creating Helm chart, you will put all your content here inside the template folder. Okay, the name is not important. You give Ram123, you give Sam123. This name is not important, but there should be one folder inside which you are putting everything. Now in this YAML file, I saw that we were using something called values file. So this values file basically contains the variable declaration, like replica count is 3. So automatically that file will pick 3. The type is node port and the load balance, the port number is 8080. So these variables like replica count 3, it is there in my values file. So if I go back to my template file, to deployment file, this guy, it will go to values.yaml, and from there it will take the replica count. What's the value? So it is 3. So yes, you can definitely hard code the value, that is also an option. But if I want to generalize it, I don't want to hard code it, and hence I have put it in a value file. So this is what I have done. I've created a chart.yaml. I've created a value.yaml, and I'm passing the values to the template from here. Now what I can do is I can simply come here and I can copy this entire content. So I can come here and say, I want to copy this, okay?
Because what is this chart.yaml values? We are taking to
see when you come with Docker, you say Docker images. Similarly, when you work with Helm, you say Helm chart. So chart is nothing but equivalent to what is your Docker image. Okay.
Okay.
Same way, you can come here, take this content. So come to the main page, code, HTTPS. This URL is what you have to copy. Come here, go to your interactive shell. Now, one thing which you need to check is whether Git is installed or not. So just come here and say Git version. So if Git is installed, it will tell you the version of Git. Now, if Git is installed, you have to simply come here and say Git pull, means whatever is there, you pull, paste, enter. So not pull, Git clone I should have done. My bad. I'm doing it for the first time, so I should have done Git clone. So it is cloning the repo. And if you come here now, you will see your entire repo has been cloned. So this is my repo. Go inside this. Okay, ls-l. And here you can see your my web. You can see your charts. And these things, if you don't need, just remove it. rm-rf. I don't need these things actually. Index.yaml, license, readme.yaml. Okay. So I simply need these guys. Okay. One is charts and the other one is my web. Okay. So if you go inside my web, you will find all your content. Charts.yaml, template, values.yaml. Come out of this. Now, I want to package everything together. Whatever you have written, I want to package it together. So here it says that you create your resources, that's done. Then you create your values file, that is also done. Then here it says make a folder with the name as charts. Okay, so let me come here. Not here, here. So as of now, there is, if I come here, ls-l, you can see cd charts. There are some items here. Okay, so what I will do is I'll just delete this guy. So let me come out and say rm minus rf, this charts. I will delete this guy. Why I'm deleting is because I already have it and I don't want to show you the old content. So let me clear everything, ls minus l. So if you see, I have only one folder, my web. Now I will come here and create another folder, mkdir charts. Again, any name you can give, your call. Now, once you have created this folder, what it says is that you should go here and do something like this. So this command basically says Helm, package whatever is there in my web and put it in this folder called charts. Okay, so this is what the command is saying. Packaging is nothing but putting everything together. So it's saying package everything what is there in my web and put it in a folder called charts. Let's run it here. And let's see what will happen if I do that. So it says successfully packaged the chart and saved it to charts my web something something something. So if I go inside this charts folder, I will see one tar zip file has been created, and this basically contains all the components which I wanted to use as a Helm chart or Helm. Now if you come out cd dot dot, there is another command which you have to run from here. Talks about another command. It says you will see your file. Now it says if you want to access it, you need to create an index. So you need to go here and you create an index file. So run this command. Why I need an index, I'll just tell you in some time. Paste it here. So it says helm repo, create an index and put it in the charts folder. So now if you go inside your charts folder, you will see two components are there. One is index.yaml and the other one is web tar dot the zip whatever is there. So I have these two components. Okay, now these two components is what I want to push it to my GitHub. Okay, so I will want to push it to this location. As of now I have so many things, but the latest content which I have, I want to push it to my GitHub location. So let me come here, cd dot dot pwd. So this is where I am. Okay, I will say git add means whatever changes I have done, dot means everything. Then I will come here and say git commit minus m, give a message. First commit, give any message of your choice. Okay, so it says I don't know who you are, so give me these details. So go ahead and provide these details. So it is asking you for your email ID and your password, email ID and username. So say git config minus global username. So email ID. So I'll provide my email ID. Similarly, it will ask me for my username. See, it is saying username and your name. So my name, the name which I use in GitHub is Vikas99341. Enter. Now you go ahead and do a git commit. Now the commit is done. It says 5 files has been changed, 3 have been inserted, and these many have been deleted. Okay. Now it has been changed, but in your local, I have to push it. So just come here and say git push. So the moment you want to push, it will ask you for your username. What is your username? So my username is Vikas99341. What is your password? So I've stored my password here somewhere in my shipment. Okay, no worries. I will create a new password. So to create a new password, what you have to do, you have to go to your settings. Okay, wait, you have to go here, your name, settings. Okay, it's also known as a personal access token. Here you have to come to let's go down, developer setting. You have to go to developer setting, and here you have to go to personal access token, and you have to create a token for yourself. Click on this token. So here you can generate a new token, and you can say, I want to generate a new token. It is asking for my password. Hopefully this is my password. So just give a note, and this will be valid for 30 days. So note is demo. And for time being, I'm giving all the access, but in generic scenario, you will not get all the access. Okay. So obviously it will depend on what kind of work you're doing. So I'm giving all admin privilege here. Okay. But in real time scenario, definitely you're not getting admin privilege. So based on that, the admin will check whatever is required and he will give it to you. Keep going down. And I generate a token. So what will happen? A token gets generated. This is my token, but you get to see it only once. So copy it and keep it somewhere. Okay. Now, once you have the token, okay, do one thing, keep it somewhere because you may need it sometime or next time also. So I am keeping it in a notepad. Okay. Now, also what I will do is I will use it here because it was asking me for password. So here, right click and simply say paste. And you will see it has been pushed. So now if I go back to my GitHub, this guy, go to your GitHub. So this is me. And go to your URL, the code which you are working with. You will see you got these two things, right? And it has been pushed 3 minutes back. Now what you do is go to setting, go to pages, and here you will get a URL. Okay, so you can use this deploy from a branch, and if you're doing it for the first time, you get this save button. So deploy from a branch, whatever it shows, save. Now once you save it, you will get a URL here. See here, this is the URL which I have got. Copy this URL and keep it with you. Okay, so you get a URL, copy this and keep it with you. Sorry. Copy. Keep this URL with you. Now, I will use this URL to create my Helm chart. Go back. Now, this is your artifact hub. Come here and say I want to log in. So I have already logged in, but let me log out. Come here and say sign in. Here it says, how will you sign in? Do you have a username or password? So I'll say I will sign in via GitHub. So it has logged in. I am signed in as a GitHub user. Here go to control panel. Here there is a Helm chart which is already there from my previous class. Let me delete all these things. Okay, now come here and say add repository. Give any name of your choice. Web server. Display name, that also web server. URL, so this URL is what you have to provide. And go all the way down here. Okay, and say add. That will validate whether it's a valid one or not. And here it says yes, it's a valid one, and you can see it has been added. Now if you want to share it with anyone, let me say I want to share it with my friends. So what I will do is I will share this name with them, web server. Okay, or I can share that URL with them. Now let me say, so this is done. Okay, let me close this guy. Okay, if I close this guy, I have to open a new this thing. Okay, so let me say if I come here and say Helm repo list. If I do like this, it says Helm repo list, no repositories to show, means you don't have any repositories in your local. though you have created a repository, but it is not here in your local. Okay, so what you do is you come here, go all the way down here. And you do a Helm repo add, something like this. So you say Helm repo add, give choice HTTPD's web server. I'll just give the name as
web-server.
let me come back here. So I guess my server would have also gone. Let me just check once. Okay, it has gone. Let me restart this server. And the अरे इंटरनेट को क्या हो रहा है, कट जा रहा है बार बार. Guys, am I audible to you? You can just put it on the chat window.
Yes, you are audible.
Yes.
Now audible.
Yes, you are audible. And I don't know what's happening to the internet. Anyhow, we have to start our.
It was disconnected.
It is getting disconnected. I think there is an issue from my internet only. Anyway, let's come here and say minikube start. Minikube start. Okay, and then I will install Helm on top of that.
What's the difference in labels and selector?
Give me some time. I'll talk about that. First, let me finish this. Okay, so Helm installation. Let's run these three commands. Back here, back here, back here. Paste this guy. Let's clear out everything. Helm should be there. Okay, now if I come and say Helm repo list, show me if anything is already there. It says no repositories to show. So what I will do is I'll go ahead and take this. So I'm saying Helm repo add, give any name of your choice. This is the URL which I got from my my GitHub, and then I have added charts at the end, and I'm going to add this. Paste this guy. Now it says HTTPD web server has been added. Now if you run this command, Helm repo list, you will see HTTPD web server with this URL is present. Now how do you run this? So you go ahead and install this. So to install, the command will be this guy. Paste this guy. So I'm saying Helm install the web for me, install the repo for me, which is here. Okay, and the name I have given as web. You give any name of your choice. Let me say I'm giving evening server, evening server web. So it is saying the name evening web has been deployed. Now, if I come here and say kubectl get all, you will see that due to replica set 3 pods are running, 1 service is running, 1 deployment is running, and 1 replica set is running. Why these many things are running? Because when I was creating my Helm chart, I have put all these things in my template. So if you see, this is what I have put in template, but this was value replica count. So I had not mentioned any value for that, right? So what happened is it went to values file. And from values YAML, it has took the value index. So where is values? This is charts file. This is my values file. So from here, it took the replica count as 3, type as node port, and port is 8080. And you can see the same thing here also. The replica count is 3. Okay. Then this is again 3, and this is node port running at 8080. So this is what I can see. Okay. Now let me take questions related to Helm first. Okay. So let me summarize everything what we have done. So what we have done is we need basically 3 things here. One is Kubernetes account or Kubernetes environment, then Helm on top of that, and on top of that I need a GitHub account where it's active and I can do everything. I went ahead and first I created a chart.yaml basically, where I will give the templates and all, basically what is API version and all. Then what I do is I go ahead and, or I can come here to this guy only.
Because if it is a private container image, then how we can able to define it
Then
in
you
the
have
YAML file?
see, then suppose you have a private repository, okay? Suppose this is a private repository, okay? Then you have to do something like this, Docker login, and you have to log in with your credentials.
Okay.
I don't remember the password. Let me try.
Then we can able to run the YAML. We can define the repository name in the YAML file and then run the
Yes.
YAML.
So if it is a private one, then you have to log in and then you have to run it. Okay.
Same way for the Git as well.
Yes, same for the Git also. So I created this charts. In this, I have this, sorry, this came later. First, we created my web. Inside that, I first created chart.yaml where I gave the basic details. Then I went to template. Whatever you want to put in your charts, whatever you want to put in your Helm chart, put it here. Then if you want to pass some values, pass it from here. Then package it. The moment you package it, you will get my whatever name you have given, it will be packaged by that name. Then you can create an index file so that it is reachable. When I say reachable, basically I want to come here, settings, pages, and this is what URL I want, and that's why I need this index.html. This URL is what I get. Using this URL, I go ahead and create my Helm chart, and I can easily use this Helm chart for any work which I want to do. Okay, so this is how I create a Helm chart and use it for my day-to-day work. Obviously, if there are 10 different people in my company who want to do the same thing, they can use it as per their requirement. Now, anyone having any questions, please go ahead.
Vikas.
Go ahead.
Hello.
Yeah, please, man, go ahead.
Yeah, this artifact hub, why this is comes in picture when we have a GitHub account?
See, GitHub is for the code, okay, but artifact hub is for your Helm chart. So there are 2 things, okay. One is you have the raw code. Raw code means you will need an environment to compile it and do 100 other things. But I have a ready-made thing which is available. So you can think like this: if I already have a Docker file, why do I need to convert it into an image and keep it in Docker Hub? Okay, But it's not like that. There will be people who will need the readily available Docker image rather than using the Docker file. Similarly, here you have the code, you have the Helm chart or the Helm thing. But at the end of the day, I need a ready-made solution. So this is that ready-made solution for me. Okay.
Okay. Okay.
Okay, so there was one more question here where one of you was asking what is the difference between these two. Let me come here. Okay, let me copy this guy. Okay, let me see, the language is YAML. Okay, so there was somebody who was asking what is the difference between app label and what was the other thing? App label and what was the other thing? Okay, so app label, you should know that app label is a unique
Selector.
Okay, see, selector is nothing but it is a keyword. Okay, see, when you remember, if you remember that diagram, I told you inside a pod container will be there. Inside the replica set, first there will be deployment, then replica set, then pod, then container. So they should know, like if there is a container, it should know which pod I belong to. If there is a pod, it should know which deployment I belong to. So this guy, app label is the guy who will relate everything. So this is deployment. So my deploy is the keyword. It is matching with your, or it is getting mapped to your replica set with the help of this keyword. Similarly, the pod is able to know that, okay, this is my pod, which has to go inside this replica set. And this replica set has to go inside this deployment. So that tagging or that labeling is done with the help of this app label. And selector is nothing but that wherever you find this app is equal to my deploy, you go and get attached to that. And one more example which I can show you here is, come here and say kubectl get all. See here, if you see the deployment, the name of the deployment is my deploy. Okay, and I'm saying inside that replica set will be there. See here, my deploy is coming followed by some random numbers, and I'm saying inside replica set pods will be there. So if you see here, this name is coming from deployment, this name is coming from replica set, and this thing is coming from the pod. So like this, so they are interrelated. And how are they interrelated? If you come inside this, oh, sorry. kubectl get all, copy. Aha. Why is this running like this? kubectl get all deployment, copy, clear, then kubectl describe So if you see here, this app label will be shown to you. Name, namespace, or label app is equal to my deploy. So wherever this label will be there, it will get attached to that. Okay. Now, one very small thing which I would like to teach you right now, and then we can close it for today. Okay. Now there is a concept of init container. Okay. So init container, because many a times they will ask you questions based on this. What is an init container? Now I'll give you a situation. Now let me say that you are an employee who is always logging from company's network. or you are using company's laptop to log in. So here you have every security feature and all. Okay, but one fine day this laptop crashed, so I have to log in, but I have to log in via my personal laptop. But do you think this personal laptop you can easily log in, or without any headache you can log in? First, you have to install some 10 softwares which is recommended by your company, and then only you will be able to log in. So basically, if you want to log in, you have to meet the prerequisite. Okay, similarly, one more example. Now let me say there is a president. He is a president of, let me say, America. Okay, and he wants to visit Dubai. Sorry for the drawing. He wants to visit Dubai. So there will be a prerequisite, right? His team will go see if the arrangement is proper or not. The security arrangement is proper. His sleeping arrangement, his all other things are proper or not. Then they will say, yes, every arrangement is proper. Then this guy will travel, else he will not travel. Okay. Now, in our Kubernetes world, what will happen? Let me say I am running a container. But for this container to come up, it will need 5 minutes. Okay. Now, if it is taking 5 minutes to run, okay, or there are some prerequisites, then once the prerequisite is done, then only the traffic should come here. Suppose before 5 minutes only the traffic is started coming here. So every time the traffic will come and it will fail. So my master node will think that this is unhealthy. This is not healthy, unhealthy. And it will go ahead and restart this. Okay, once restarted, again it will start sending the traffic. Again the same problem. It will take 5 minutes to start. You're not giving him 5 minutes. Again it will restart. So this problem will continue and your actual container will never ever start only. Okay, so I want that this kind of problem should be solved. So I will teach you a very small concept, but a very important concept of init containers. So let me come here and say init containers in Kubernetes. So init containers is just like any other container. The only thing is there is a prerequisite attached to the container. Let me take it. Oh, battery is about to die. Give me 1 minute. Battery is about to die. Okay. So the concept of init container says that these are specialized containers that run before the application container in the pod runs. Init container can contain utilities or setup which are not present in your app image. Okay, so basically what it is trying to tell is, come here. See here. So if you see only till this point of time, let me take this much only, or let me take full only. But okay, if I show you this much, this is okay. It is API version. There is a kind which is pod. In the metadata section, I have given a name, I have given a label. The label is my app and it should match. Then in the spec section, I'm saying a container should run with the name as my app container, and it will run an image called busybox 1.28. And while running, it will run a shell command. sh is shell command, -c is for container, and inside the container, it will run this echo, the app is running, and it will sleep, or it will stop for like how much? 60, say if you divide 60 minutes. So it will sleep for this much. So in a general scenario, if you run, it will immediately run. There will be no problem. But now what I'm doing is I'm putting a special condition here. Init condition means before this thing initializes, I want that there should be a service with the name as my service in the cluster. It should be up and running. There should be another service, MyDB, which should be there up and running. So basically I'm saying my service and MyDB and my service, there are two things which should be up and running. If it is up and running, then only allow this to run. Now if I run this, let me show you this and then I'll explain it again. So again, come here, just say nano init example, again give any name of your choice. Paste this guy, Control X, Y, enter. So what will you do? kubectl kubectl apply -f and this init. Okay, it says unexpected line number 17. There is a 19. There is a problem. Let me come here. Nano. So I think there is some problem in the copy paste. Let me copy it correctly first. Control C. I think there is a problem. There is some line which is not getting copied, waiting. But after that also there should be something. Wait, I have this in my GitHub. I'll take it from there.
So in the meanwhile, like regarding that, what is a help chart like you created in the replica, you were not mentioning the number, like you are mentioning something.
But it is there in your value.yaml, na? That content is there in your value.yaml.
Yeah. So why can't we give the number, like instead of giving that?
No, you hard code that value. There is no problem. See, I am showing you different ways. If you don't, I told that if you don't want to hard code, then you can put it like this. Like all the day, see, till now, whatever we have done is we are hard coding the value. We are putting 2, 3, 1, whatever you want. You are hard coding the value. But in case you don't want to hard code the value, then you can pass it via value.yaml. That is an optional thing.
Okay, and why you created index.html kind of YAML there?
Because that web page is what I want to access.
Okay, it will be empty. Just you touch the HTML, right?
No, it will be having content. It will have content. It will not be empty. See, it is auto-generated, but it will have something. So
okay,
I'll come to that. Let you finish this. So I've created a pod. So come here and say kubectl get pod. Now, if you see here, this pod is init status, means it is waiting for someone. Okay, if you go inside, it will tell you that it is waiting for those two guys. Who are those two guys? So it is waiting for these two services to come up. One is my service. It is doing a NS lookup, or it is looking for this service with the name as my service, and it is looking for a database with the another service with the name as MyDB. So unless and until it is provided, it will keep waiting. So what I will do is I'll go here and say nano service.yaml, and I will provide those two services now. So let me just come here and provide those two services. Now, the moment I provide those two services, immediately it will come up. Okay, just let me come down here, Let me copy these two services. So basically, I'm creating one service with the name as my service and the other service with the name as MyDB. Okay, Control X, Y, enter. Come here and say kubectl apply -f service.yaml. Now, the moment this is created, come here again and say kubectl get pods, and you will see that it has come into running status. From init status, it came to running status. Why? Because now these two services are available. So it is like a conditional execution. You say that if the prerequisite is met, then only you go ahead and do the next activity. It is very helpful because many a times unnecessary, there will be a problem if the prerequisite is not met. So this concept is known as init containers. Okay. Now I'll take questions from here. If you have any, please go ahead.
So how this master node knows that like whether this services are what do you say is waiting, everything is done with the
This
container.
thing will be there in your etcd. So etcd is the brain of the cluster, and here you have precisely mentioned init containers, and it has to wait for these two containers, these two services. So it is looking for the, so when I started teaching, I told you etcd is the brain of the cluster. It will contain the current state. What is the actual state? So in the actual state, it doesn't have these services. My service and this service is not there. So it is waiting. The moment it got it, the current state has changed. It found it and it is running. So all the details will be stored in your master node in the etcd. So guys, definitely these things will need practice. Please do it. Yeah.
Explain this my service file.
This is simple, no? What is there to explain here? This is just like any other service file. App version v1. The kind is service. In the metadata, you have given a name as mydb. In the specification, you are saying it will be TCP port number 80 and 9377. You have not mentioned the type, so it will be cluster IP. Similarly, here also you're creating a service. The name is my service. You're opening another port, internally 80, externally it is 9376, but you're not mentioning anything. It will take cluster IP. And if you come here and say see here, if you say kubectl get service, you will see these two are there with the name as cluster IP, internally running at port 80. This is again running at cluster IP with this port number. Okay.
And sir, first file also.
First file I have already explained. Please pay attention. Cannot repeat everything multiple times.
No, sir, there was some commands, so that's why.
Shell commands I told, right? See, when you run this, it is
this init container command, sir.
It is v1, starts with a version 1. Kind is pod. In the metadata, you give a name, you give a label. Then in the spec section, you go and say that this is the container which I want to run. The image of that container is busybox 1.28. And here there is a command. It says when you spin up this container, inside the container, run a shell command. sh is shell command. -c means inside the container. Echo is a print command. So it will say the app is running. So this will be printed with a, so this much content will be printed. This much content will be printed inside the container. And it says after that, this is and after that sleep for 3600 seconds, which is I think 60 minutes or 1 hour. Then in the init container, it says the name is init my service. Give any name of your choice. It will run an image called busybox. And here the command says that until you find a service, until ns lookup is find command kind of thing. Until you find a service with the name as my service inside this location, var run secret kubernetes.io service account namespace service. So this is the path where all the services will get created. So it is saying unless and until you find inside your cluster, unless and until you find this guy, my service, keep looking for it. Same is here. Unless and until you find this guy, keep looking for it. Now this is not satisfied because this was earlier not present. So it is not satisfied. If this is not satisfied, definitely this will never get created. And hence, in the beginning, my service was in a init state. So I showed you in the beginning that it was in init state. The moment you satisfied your requirement, it came into running state. And if you come here, you can see that. Copy. kubectl describe, paste describe pod application pod. So here you can see. First it started here, then busybox was pulled, then created init my service, then started init my service, then init my db, then init my db, and finally your my app container got started. So there is an init condition which has to be satisfied, or a prerequisite which has to be satisfied, then only it will start the work. And here it is mentioned.
We use this in the real time?
Yes, definitely. I just now gave you an example where I told you that there is an application which takes 5 minutes to come up. If you just, it came up and you start sending the traffic, which is the normal behavior, because the moment the container comes up, my master node will say that it is healthy and it will start sending the traffic. Obviously, it is yet to come up. If it is not ready, it will fail. And you will see that it is like in restarting mode. Always when you go inside, it is in restarting mode. You will never understand what is wrong, because according to master node, it is up and running, but it is not taking the traffic, but still it is going in restarting mode. So it is 100% used in your real world.
But master node doesn't know that, like, if the service is up and running on the node, so the service has to be started, right? When the node, when the
that condition you have put in your pod. See, that condition you have
Yeah.
put in your init pod. See, for a person who's seeing from outside, see, master will see from outside. So for master, he will think like it is running, because the status is like running. So he will think it is running, but it is not actually running.
Okay. The service point of view, then init container will be helpful, will be the use for the etcd to track.
Correct.
And in the artifact, like, you created the image, so we can modify that image, right? So it is like a ready-made thing.
Correct. You have to basically pull that image to your local, then whatever changes you want to make, you make, and then again push it back.
Okay. Okay.
But while pushing it back, you push with your name. Don't push with my name, because it will go with my name in my Docker Hub. And obviously you don't have credentials, so it will not go in my Docker Hub. So push to your repo with your initials.
Okay.
Okay, fine. See you then, guys. Thank you, guys. Bye.